It says to use the square root property to solve the equation. Well, we're going to look at two separate equations here. Starting with this one, it says x squared is equal to 49. Well, you can almost look at that and just by inspection realize that the solution would be 7. X is equal to 7 because we know that 7 squared is 49. So you think, okay, that's easy. But keep in mind, that's not the only thing that we can square to get 49. If you take x equals negative 7, if you square negative 7, well, negative 7 times negative 7 is a positive 49. So there's two solutions to this equation, plus and minus 7. Well, to look for a general way to solve equations that have x squared in them, we want to keep in mind that we came up with 7 because we knew the square root of 49 was 7. So if we have an equation that looks like this, x squared is equal to c, some number c, then the solution can be found by thinking of it as taking the square root of both sides. If you take the square root of x squared, you get x. If you take the square root of c, you get the square root of c. But remember, there's two solutions. There's a plus and a minus, just like there was up here with the 7s. So this is called the square root property. If x squared is equal to c, then x must equal to plus or minus the square root of c. This comes in. We can use this when it's x squared, just something squared. You see in this next example, it's not quite like that. We don't have just x squared. We have 3x squared is equal to 7. So we want to make it just x squared, and we can get rid of the 3 by dividing both sides of this equation by 3. Those 3's cancel, so we have now x squared is equal to 7/3, which is what the square root property is, designed to solve for us. We solve this equation by taking the square root of both sides. The square root of x squared is x is equal to, plus or minus, remember, the square root of that number, 7/3. Now remember, there's a property of radicals that says if you have a fraction underneath the square root, or under any radical, it could be a cube root for that matter, but if you have a fraction underneath a radical, you could split that up into two separate radicals like this: the square root of the numerator over the square root of the denominator. And we do that because we want to make sure that we don't have any fractions with a square root in the denominator. When you have a square root in the denominator, we fix that by doing what's called rationalizing the denominator. Because see, the square root of 3 is not a rational number, so we want to make it a rational number. That's why we call it rationalizing the denominator. We do that by multiplying the top and bottom by that radical, by the square root of 3. Because we know that the square root of 3 times the square root of 3 is going to give us the square root of 9. Because remember, when you multiply two radicals together, you just multiply the things underneath the radicals. So you're going to get the square root of 9. Well, the square root of 9 is 3. So the radical's gone. We just have a 3 down there, which is a rational number. We do the same thing to the numerator, so we multiply the square root of 7 times the square root of 3, which is the square root of 21. So the solutions to that original equation are plus or minus the square root of 21 over 3. And we separate those to emphasize there are two answers by writing it like this. One answer is the square root of 21 over 3, and the other answer is negative square root of 21 over 3. So you got the positive and the negative answer. So those are your solutions.